Thank you very much. It's my great pleasure to have the opportunity to share with you some ideas on the topic, challenges and opportunities beyond MOOCs. So I'm T.C. Pong. This is actually the HKUST campus. It's a beautiful campus, I have to say. You have not been to our campus, you're all welcome to visit us. We are a very young university. We celebrated our 25th anniversary last year. So we have a lot to learn from the old university like Kyoto as well as Seoul National University. But as far as a MOOC is concerned, we started quite early. Actually, we joined Coursera as the first university from Asia to involve in the MOOC movement. Now, for today, the outline of my talk, I'll first give you an overview on some recent trends and development in education, and then I'll share with you what we have done through the MOOC and blended learning initiative. Then I'll talk about using MOOC for blended as well as experiential learning to address some limitations of a MOOC before I conclude. Now, before I talk about MOOC, I want first to talk about some recent trends and development by combining pedagogy as well as technological aspects in education. With a better understanding of the learning process, education has gone through a paradigm shift from teacher-centered learning to learner-centric learning, and as well as changing the focus on intended learning outcome, as well as the mastery of the subject rather than just the content to be delivered. These changes has led to increasing emphasis on active and collaborative learning. On the technology side, advances in internet and web technologies has allowed learning to be carried out anywhere, anytime using mobile devices. And research in big data and knowledge mining has enabled learning analytics to be carried out to better understand how students learn and how teachers can enhance their teaching and learning. Also, in emerging technology, including AR and VR, has created more stimulating learning environment that will allow active and collaborative learning to be carried out. The convergence of the technological as well as pedagogical development has led to the replacement of the traditional lecture style teaching by the new pedagogies, including blended learning, MOOCs, and experiential learning. I'll talk more about these later on. So, as you know, lecture style teaching has often been criticized as not very effective. And the criticism can be summarized very well by a quote attributed to Mark Twain over 150 years ago, which says, college is a place where professors' lecture notes go straight to the students' lecture notes without passing through the brains of either. I think this is still true even nowadays. So how can we make teaching and learning more effective? Perhaps we can go back even further. Over 2,000 years ago, there's a Chinese philosopher called Shunji. He pointed out in his quote that, well, you may not be able to read the Chinese, but even if you do this old-style Chinese, you may not be really understand that. But the English translation is that, tell me and I'll forget. Like what I'm doing here, I'm telling you something. I'm pretty sure that by the end of today, you would have forget most of what I said. And then, show me and I'll remember. That's why I'm using PowerPoint. Hopefully, by showing you something, you'll remember better. But most importantly, is involving the learner in the learning process that will make them truly understand. This has been recognized over 2,000 years ago, but we have not really been practicing that. So, and there's been a lot of study showing that, for example, in this article published in Science, you can show that performance could be improved in different metrics, including attendance, engagement, and most importantly, in the learning outcome. Now, this study is based on some face-to-face instruction. Now, with MOOC, you know what is MOOC, but how can we make MOOC more active. Also make it student, the learner, involved in the active learning. So as you know, in MOOCs, students would be watching video. But what I want to emphasize is that MOOC is not just watching video. You know, you watch YouTube. Some of you may have watched TED Talk. These are very stimulating talk. But these are passive. It's still one-way delivery. You will forget that very easily. Like what I talk about, tell me, and you will forget. So in MOOC, in addition to watching just the online video, learners are involved active in the learning process through online quizzes, discussion forum, and other activities. And more importantly, MOOCs can go beyond just offering courses and content. The MOOC platform will be able to collect the learning activities from the learner. Every mouse click you make, every keystroke that you enter will be recorded by the system. So by performing learning analytics, that will allow us to better understand how students learn and how teachers can improve their teaching. So for HKUST, as I mentioned, we joined Coursera in 2012, and then we joined edX in 2013. So far, we have offered, well, this is not up to date. We now have over 40 MOOCs now to over 1 million learners from around the world. And our MOOCs are actually quite popular. For example, last year, in 2016, edX ranked the top 10 most popular edX courses. HKUST's course, Introduction to Java Programming, is one of them. And you can see that there were courses from Berkeley, MIT, and Harvard. This year, we also have a course that's on the list. So here you have around 17 courses. And one of these is voted by the staff as the top courses. Again, this is the Java Programming. This is actually a course offered by myself, so I can talk more about that. So this is a Java Programming course. We started to offer that in the summer of 2014. And so far, well, some of the data is interesting. You can see that the students are from over 180 countries, and the demographic, including mostly students from the United States, but there are also a large number of students from India. Actually, this is not quite surprising because in India, there's a lot of interest in IT. Java programming is, of course, in the IT area. And you can also see that the demographic includes students not only at the college level. There are actually around 30% of the students are from secondary school, although this is a course at the university level. I have been offering this course for the past 3 years. So far, we have over 300,000 students registered for this course. I have actually done some computation. I've taught for over 30 years. I'm actually quite old. If I can reach to around 1,000 students every year, in 30 years, you can do the simple arithmetic. I will get around 30,000 students. In order to get to 300,000 students, I need to teach 100 years. I'm pretty sure that I won't last that long. So you can see this one impact of MOOC. Now, as I mentioned, doing the learning analytics is very important. So here, we developed a tool called VisMOOC by Professor Huamen Xu to basically visualize the data we collect from the MOOC. By just giving you the data is not meaningful at all. So a lot of the instructor, in order to be able to make sense out of the data, somehow you have to do the analytics, you have to be able to visualize the data. So basically, the system will analyze all the activities related to watching a video. Well, when you watch a video, you can pause the video, you can change the speed of the video, you can fast forward, you can rewind. For example, here, these are some of the fast forward activities. Each line represents a fast forward. So a lot of students actually go from the beginning to all the way to the end. That means they did not watch the video at all. For whatever reason, they may know the subject already. Here, the blue lines represent the rewind. So each line, students go from here to, this is actually synchronized with the video. Here is the timeline of the video. So some students here go from the end all the way to the beginning. That means they want to watch the video again. Some would just rewind for a very short duration. Perhaps when the video talked about that particular concept, it was not very clear. All right. So by analyzing these kind of activities, we have developed, I'll show you a video on exactly how this system works.
Selected from MOOC platforms.
Okay,
a lecture video can be selected for carrying out the analysis. You'll find three
these
graphs under the video.
Activities.
A graph at the bottom of the window represents the different mouse events, namely play, pause, seek, rate change, start, and error. This is called a stack graph. One can move the cursor along the graph to find out the frequency of different mouse events entered by the users. Since seeks can go forward or backward, they are further represented in two separate graphs. The orange strips here shows the forward seek event. Each line in the graph represents the starting and ending position of a forward seek. The blue strip below it shows the backward seek events. The backward seek events are of particular interest. Let's switch to another lecture video. This lecture compares the education systems between China and the West. One can easily see that there's an obvious peak here in the stack graph. One can click here to find out the corresponding location in the video. The topic being discussed here is about income distribution of students in the US. By selecting demographic information, one can look at the activities of students from different countries. Let's take a look at students from the United States. It's clear that the peak remains, because this is probably a topic that's of interest to US students. Let's switch to China. Interestingly, the prominent peak disappeared. Perhaps students in China are not as interested in the topic. Observations like these may impact how the instructor would design the lecture or learning activities on this topic.
So you can see that this is the learning pattern for students from China. Well, here you can actually see a peak here for students from China. So you actually go to that particular video location. Well, you have probably guessed it. This is about a topic related to China. And you can see that students from China pay more attention to that. But the instructor probably wants every student to learn about what's happening in the other country, right? So you can see that the intention of the instructor may not always match how the students learn. By analyzing, you can really get some idea. Not only that, you can look at the demographic, you can also look at different student group, different age group, students from different background on how they learn. Another important aspect is to look at how the students interact through the discussion forum. All right, so after I post a comment, how the other students react to it. So this is called social network analysis.
Feature offered by this analytic tool is for the discussion forum. By clicking on social network under forum, we can visualize how students interact with each other through their discussion postings. Each student is represented in the network by two attributes. The first is his performance in the course, which is color-coded in red if the student performs well, or green otherwise. The second is on how active is the student. An active student is represented by a larger circle, while an inactive student by a smaller one. We can look at the interactivities of individual students by moving the mouse around. For example, this is a very active student who also performed well, as indicated by the size of the circle and the red color. You can see that he or she interacted mostly with other high-performing students, as indicated by the red color. Let's look at another student who didn't perform as well, as indicated by the green color. Interestingly, he or she interacted mostly with students who also didn't do too well. Perhaps the instructor could step in to provide some help.
So you can see some pattern on how students interact with each other. You can also find out, well, how students from different countries interact with students from their own country and so on. All right, so this is on social analytics, but more importantly, is on how we use this learning analytics. So I'll show you some examples on that. So here is the course that I taught. It's about a concept called abstraction. Well, by abstraction, it means it's abstract. It's something that's difficult to understand. The basic idea of abstraction is to basically separate the what and the how, right? If I tell you that, would you understand what that means? Probably not, right? So if you, for a certain concept, you want to use example to illustrate, to explain to the students. So here, as you can see, when I talk about abstraction, there's a lot of activities, and students rewind, watch the video again. That means I did not explain the concept clearly to the students. And when I look at the video again, this is what I found. This is the example I use.
Come up with other daily life examples using abstraction. In driving a car, when we step on the gas pedal, the car is supposed to accelerate. And when we step on the brake, it is supposed to slow down. But we don't really care the mechanics behind how they work.
So the what for the brake or the gas pedal serves certain function. But the implementation is very complicated. for those non-mechanics, you may not be able to understand. And you don't need to understand that in order to drive a car, right? That's to separate the what and the how. Well, students, you can see that did not understand that from the graph. So I use another example here. I could give an example on when you go into an elevator, a lift. You push certain button for the closed door, you know the what. But this electronics and mechanics, when you go, push a button number 5, it's supposed to go to the 5th floor, that's the what. But the how, again, you don't need to understand. I thought these are good examples. But students still don't understand. So I simply ask the students, why don't you give the example yourself? So after that, after I post an exercise for the students to post the example by themselves, well, you can see that there are a lot of activities. For example, there are over 500 postings. And one student gave the example, when you do Google search, you know the what. You want to search for something related to the keyword, but the how, the algorithm behind Google search is so complicated that none of us will understand, right? So that's, again, to separate the what and the how, and see what happened. The other students replied by saying, I get it, thanks. Nice explanation, nicely said, very nice example. Well, actually, I get a little bit jealous because I seldom get places like that. But this indicate that as a teacher, I use my approach, my example, to try to explain certain complicated concepts. I drive a car almost every day. I go into an elevator in a lift almost every day because in Hong Kong, we have all these tall buildings. But we have forgotten that we have students who are still not even adult. They cannot drive a car. We have students from Africa who have never gone into a tall building. So we use examples that are familiar to us. That's teacher-centered, without thinking about how students learn. Now, by involving the students themselves post examples that are more related to the other students. So you can see that by using this kind of approach, you can really improve the teaching. And the example now is the example that I use in class. And the students actually get a better understanding on that. All right, so now, as, I want to switch topic now on how we can actually use the MOOC for other purpose. We all talk about flipped classroom. I have done that many times. All right, but what I'm going to talk about is a different kind of flipped classroom. I'm calling it a synchronized flip. The idea of a synchronized flip is that for a normal flipped classroom, you synchronize the video and the in-class activities, right? Every week you have the video, you have the activities, video activities, they're synchronized. But what we are doing here is asynchronized in the sense that the student will finish all the online activities, just a MOOC, before they come in for the face-to-face section. All right, so that's why I'm calling it asynchronized. So here, one pilot that we run last summer is to have students from around the world. 1/3 of the students from Hong Kong, around 1/3 from overseas exchange, and 1/3 from mainland China. As I mentioned, they first completed the MOOC, and then they would be doing some assessment because I cannot rely just on the online assessment because you don't even know whether the students did the job by themselves, right? So, and if they pass the assessment, then they come in for a 2 weeks face-to-face summer section. Only 2 weeks rather than the entire semester. At the end, they take an examination. If they pass the examination as well as other requirements, they actually earn credit for the MOOC. But usually when you take a MOOC, you don't get credits. You get a certificate at the most if you pay some fee. All right, but here, the students actually get the credits. We issue the students the transcript after they actually finish the course. So in a way, for the exchange students, they come in, need only 2 weeks rather than an entire semester. And then another aspect of this pilot is that we want to involve professors from not just HKUST. So we actually look at the MOOC. This is my course. And then I found that a Spanish professor also offers Java programming. Toro probably recognized that this is Carlos. So I brought him just for 2 weeks to teach the course together with me. So here, you can see that this is him, this is me. This is the flipped classroom setting. You can see that the chair and the tables can be moved around. And then I also try to introduce activities here. You can see that the students are wearing these red-blue glasses for seeing some virtual 3D images, right? Again, I want to stimulate the interest of the students. Now, more importantly, I want to use learning analytics in designing the in-class activities. So here, you can see that by analyzing the online activities, there's a lot of activities here. You can see the peak. And this is about a concept called constructor. But you don't need to know what exactly is constructor, but because of that, I try to design some activities. Is to go through the code as a group. So it's basically a debugging all the exercise, and then try to fix that. So this is what happened in the classroom setting. The student work on the problem. We have the TA going around. So at the end, you can see that I'm throwing some candy just to motivate the students. Here, the students try to answer my question. What's the problem there? So this is about constructor. So the activity is designed based on the learning analytics. Have no type. All right. So do you work on that yourself or as a group? As a group. Okay. All right. So you get it. And you can see that the students are actually very enthusiastic, trying to answer the next question. All right. So this kind of activity is important in designing flipped classroom teaching. Another activities that we introduce is by the Spanish professor. I've never heard of Kahoot before last summer. And this is what has been using. Kahoot is basically a polling system, like a clicker. But then we have some game element in it. All right, so the students will try to answer the question as fast as possible. At the end, there will be a winner. All right, so now this is the activities that is designed.
Again, the value of I is 0 at the beginning. What will be the value here?
So this is the interface. The student try to look at the question and then look at the code and find out the bug. All right. So in fact, it's a trick. So he's saying that there's a trick. He's telling the student there's a trick, and the students now realize that they're being tricked. So see all the laughing there. So, see, this is the correct answer.
There's a little trick.
So this is the correct answer, but only 8 out of 30 some get the correct answer. Now, he's trying to explain that there's a bug here, that's the error. Now, I'm not trying to teach you computer programming, but what I want to point out is that if I simply tell the students that this is a bug, again, at the end of the class, most of the students will forget about that. By involving them in activities like this, and most of them make mistakes, most of them now will remember this is not the right way to do programming. All right? So this, again, this learning analytics, by using learning analytics, we also found that is a problem. So, and then at the end, as you can see, there's a leaderboard. All right? Students are really more enthusiastic in participating in these kind of activities. Now, I want to move, okay, so we also done some survey to ask the student, do you like Kahoot? Well, actually, only 2/3 of the students like it. And was it fun? Again, 2/3. Well, this is understandable because for the student who get the wrong answer, they wouldn't like it, right? But what is interesting is that when they ask, did you learn? A lot more students think that they are learning. And would you like to have more? Even though if they don't like it, they don't find it that fun, but many more like it, like to have more. And then we also done some survey on the feedback questionnaire. From a score of 0 to 100 on the average, most of the students like the experience. For example, here, the online content and activities prepare me well for the face-to-face section, which is important to link the online and face-to-face. And here, there have been a lot of opportunity for me to interact with the instructor, TA, and student, which has deepened my learning. Again, the students like that. So we look at the feedback from the student very seriously. As I mentioned, this could be used as a model for expanding the student exchange as well as faculty exchange. I want now to talk about another project, which is for our first-year engineering students. All right, well, we want to basically to expose our first-year students to knowledge and skills from different engineering disciplines. Because for the high school students, when they come into the engineering school, many of them don't know much about what is engineering. All right, and then at HKUST, the students come into the School of Engineering without a major. We want to give them a more informed decision. So we want to give them introduction to different engineering disciplines. Now, the problem is that for the first-year engineering student, they have very different background. If we just offer a course, it's difficult to decide what to offer or what to not to offer. So we put the basic knowledge online so that the students can learn at their own pace. All right? And then after that, they will be engaged in team projects to connect what they learn in the experiential learning mode, to do some hands-on projects and so on. And so this, we call that a blended experiential learning experience using MOOC. So this is the online part. We are doing it using the HK MOOC, a MOOC based on open ethics developed for the Hong Kong tertiary education sector. And here we have 3 components: mechanics, electronics, and computer science to develop Android app. Again, some of them may be something that they know already, but some don't. So they learn at their own pace. After that, also, when they learn at their own pace, we need to let them know how well they are progressing. Otherwise, they would wait till the last minute. So every week, we send them the progress. For example, here, this basically gives you the top range and the lower range of the activities. And this is where the students stand. So for example, these students have done very well. They are all at the top range except for the last one, right? And then this one here, you can see that he or she has done quite well in the first 4 weeks, but not for the last 2. So we let them know how they are progressing relative to the rest of the class. That's very helpful. And then this is the face-to-face section. After they finish the online, we bring them in the classroom setting. And, well, this is something with the problem here, but so I flip it. So the flip classroom. So here you can see that it's a drone, okay? So, and it's actually the latest drone. It has the ability to follow the gesture, right? So you can see that when the drone here. So it's basically follow that. Well, the reason why we want to do this is that, well, drone is very fascinating. But when I ask how many students have actually flew a drone before in the beginning of class, guess how many among 60 students? 0. They heard about drone, but they have never tried it because in Hong Kong, it's difficult to find a place that you can legally fly a drone. But then on campus, after that class, every student, 100% of the students had the opportunity. Now, what is even more important is that after that, we took apart the drone, explained to them the technology behind it. There's a GPS, there's a gyroscope to keep the balancing of the machine, and so on. The students are really very attentive and have a lot more questions. Right? Again, if you simply explain to them the technology without actually having them flying a drone, they would not be interested. So we really want to expose the students to the new technology, the emerging technology like the drone. And also here, we want every student to have the opportunity to play with some power tool. Engineers, they really need to work. So they're drilling, they're using the saw, and here, this is the 3D printer. After the course, every student would have the experience using 3D printing because one of the components of the drone that they build has to have a 3D printed component. And then they are doing the electronics, all right? And we also introduced to the students the idea of design thinking. Design is essential in engineering. And in design thinking, building prototype is also important. So here is an example showing that before they build the airship, so they are using just a fan in blowing the balloon to learn the concept about the balancing of the machine and so on. So after that, they would actually build the machine, okay, with a larger balloon, and then here you have the propeller being controlled by Arduino and so on. So in the first year, we want to introduce to them that kind of concepts. And then here, After that, they actually participate in a competition. So in this competition, basically they want to fly the drone to pick up the objects here. This is actually the bonus. If they pick up this object, they'll probably be the winner. So here is a video showing. So you can see that, that they have very different kind of machines. Okay, so basically, I think it's a video showing how the airship that they built work in the competition. Now, before I end, I want also to introduce to you something that we participated called the Global Virtual Exchange. Well, you know what is an exchange program. Students go to a foreign country physically for 1 semester usually. But now, there are limitations. For example, you have to usually spend 1 semester. This could be very expensive. And also for certain students, if they cannot get the credit transfer back, there may be delay in the graduation. So here, another limitation for HKUST is the housing. Right? You know, in Hong Kong, housing is very expensive. During the regular semester, it's difficult to find place for all the students. But in the summer, it's very different. Okay? So here, for the virtual exchange, in order for that to work, we actually brought in our partners. There are 8 other partners in addition to HKUST, including in Europe, in Australia, and in the US. So after this meeting, we actually signed the agreement to set up these Global Virtual Exchange Alliance with these universities. What is different between just a MOOC and these is that these are credit-bearing online courses. These are fully online courses, but together with a proctored examination. So we'll be sending the examination to the location of the partner institution. The student would take the exam in a classroom setting with an invigilator. So that would be monitored rather than just doing everything online. But the learning part is online. And then at the end, the students get credits from the host institution. We issue them the transcript and credits. So this also provides them with a culturally diverse online learning experience, right? Not physically, but you know nowadays the students really spend a lot of time online, right? Like the Facebook and WhatsApp, other social media, right? These would give them an opportunity to learn something useful online. And you can see that this is the web page that we set up for our students to register for the courses. And it's actually a very rich of collection of courses already. This is the first year of operation. You can see some engineering courses, also some health and medicine courses, public administration. And we have some language courses, science courses, basic science, and then even anthropology. So these are courses offered by different universities. And as a science and technology university, this is very good because we cannot offer as much this rich collection of courses because of the faculty that we have, mostly related to science and technology. But now they have the opportunity to take courses from our partners without leaving Hong Kong. So just to summarize, we use MOOC as a catalyst for improving teaching and learning on campus by offering branded, flipped, and experiential learning courses. And as I mentioned, it's important to use the learning analytics in order to really be able to use the MOOC effectively. And also, we use MOOC to outreach to prospective undergraduate, even postgraduate students. As I mentioned, there are high school students taking the course. In fact, we now get a lot of applicants who have taken our MOOC and now trying to apply to HKUST for admission. And we also try to package our MOOC into massive open online programs and degrees. Like we talked about before, there are degrees like in Arizona, talked about by Toro, that the entire freshman year is online. So these are, I'm calling these massive open online programs. And Georgia Tech and MicroMaster, these are degrees. And then use MOOC as a platform for inter-institutional collaboration. This is a very important strategy by HKUST. In fact, we are now working with some Asia university to set up a virtual exchange program just for Asia. Well, for the global virtual exchange, it's a good idea, but one problem is that since it's covering 24 hours of time zone, it's impossible to find an exam time that would fit all the students during the daytime. But within Asia, it's easily doable because the time zone is just within 2 to 3 hours. All right, so I hope that we can all work together to make more meaningful, useful application of MOOCs. Yeah, thank you very much.